Nothing worse than recording yourself. Okay, this is going to be about project requirements and constraints. I hope not to bore us all to tears. These notes mainly come from, I can't take credit for this myself, even though my name is on the slide. I got this from a previous instructor, and so a lot of the quiz is structured after his style, which may lean towards one or the other two political sides. And that may be obvious as you take the quiz. All right. So, first I just want to talk about, at least for the electrical engineers, and I think mechanicals follows this project development roadmap. And this goes for all projects. This is going to be slightly different from what Kevin talked about last week as far as project development or project management. And so, when we go into what we call the initial concept, there's a lot of questions we have to ask. What's the problem that we're being addressed? Who's in charge? And ours, we say, who's the team, who's the advisor, who's the sponsor? And the reason why we break it up into those three things is we want to know who the workers are, we want to know who the sponsor is, the customer, that's who we're going to be delivering the goods to, and the advisor is kind of the liaison between the two, and a lot of people would say that they're the manager, okay? Now, you guys in your own project should be your own manager. You should just be using your advisor for help and for if you need anything from the sponsor. That's the way with this particular project. We also need an initial list of deliverables, okay? So we want to know what you're going to be giving us at the end. As Kevin said last week, if we have a time and a budget constrained project, that means the deliverables might also change over time. That makes sense. If we have to be done, we're going to be done by the end of senior design. And we have limited resources. Since both of those are constrained, our deliverables are going to be what might have to change over time. And this is normal for senior design projects. I don't want you to look at it like that's what you're going to do, though. Okay? I don't want you to just, and that's why we have a separate sponsor. You have to get those things approved, all the changes as the deliverables change. You have to get that approved through the sponsor, which is why it's good to have a separate sponsor from the team. Okay. In the preliminary design stage, so we have basically 4 stages. The second is preliminary design. We talk about the problem that's being addressed. We talk about the functional operational requirements, and since requirements and constraints is the topic of this talk, that's something we want to kind of keep in our mind. This is where we start talking about requirements, and so we'll define that a little bit later on. We need to talk about what kind of system interfaces, what kind of constraints, that's the other part of this, what kind of conceptual system description. We're going to have final list of deliverables, a schedule, budget, milestones. And we are almost to that time where we want a kind of a schedule, budget, and milestones. So for the electrical engineers in the near future, we're going to do, go to the previous one, and we're going to do an initial concept a design review. We call this initial design review an IDR. Grab a quiz. Oh yeah, you ran. Yeah. So we call this the IDR, and we're going to be having this in a couple weeks after we get our group together. We're able to get these things together. End of this semester for at least electrical engineers. I don't know. Is this consistent with what you do, Steve?
A little bit different, but also that
Okay. Towards the end of the semester for at least the doubles, we're going to have a preliminary design review. And so these are the things that we're going to want to know. We're going to want to make sure that you're on track, basically, okay? At this point in time, most of this is going to be, at the end of this first semester, most everything is going to be in CAD form, or design form, or paper form. We're not going to have an actual physical deliverable at that point in time. Which leads us to about mid-semester, next semester in the spring. We're going to have intermediate design. We do this right around spring break. And basically this is, you better have your crap together. There better be something that's being built. We better be able to evaluate it. We better figure out if it's working somehow. And we want to update the schedule, the budget, the milestones. So that's the basic idea. Still, we have the requirements and the constraints we need to talk about a little bit later on. Okay. Finally, for the final design, you're going to address the problem that you're addressing, the requirements, constraints, the deliverables, the final design description. So this is the final report. The compliance to requirements by test and or analysis compliance to the constraints, which you're going to have to make an argument for. System demonstration is often part of this, okay? This is where the demo gods are unfavorable for you, right? And I always remember there was one group, they had a quadcopter as part of their senior design project. They're at the final design review, our IAB, the Industrial Advisory Board members, were there. And even prior to this, one of them had went and grabbed the quadcopter as it was flying and tore up his hand. Okay, that was prior to this. But they said, all right, we're going to test this quadcopter. It was supposed to maintain level of flight, and the thing just went straight into the ceiling. Okay, always, every time, demos go wrong. But we hope that yours go a little bit better. The other place that we're going to have the presentation of the deliverables and system demonstration is at Texpo. Yes, there will be a Texpo this year, and yes, you will be presenting at that with your equipment, if that makes sense. And so that's going to be part of our final part. For most of you, it makes up a portion of your grade. So does the presentation, so does the final report. Okay. Overall results and conclusion is also very important to most people. Okay. Okay. In the engineering design development, we worry about schedules and budgets. I think everybody kind of understands that. And that maybe budgets we don't, but we take engineering economic analysis, hopefully for that, just a little bit. Parts and equipment specifications. We need to know which parts we're using, especially if we're going to pass, if this is a multi-year project, we're going to pass it on to somebody else, they're going to want to know what parts we're using. This is especially important when you get an actual job, because once you're done with your project or once you quit, someone else has to take over. So documentation, finalized drawings, fabrication procedures. So you got to figure out how this thing is going to be put together. It's one thing to make one of them, but it's another thing to make whole bunches of the same thing. Acceptance test procedures, manufacturing procedures. You got to go from just being able to manufacture it or being able to build it, fabricate it, to actually having it do in mass. Prototype fabrication procedures and testing, so that's a little bit earlier on, and operational maintenance manuals. And I think we're all familiar with this. We've gotten something from Harbor Freight or some other business that was obviously made in China, and we open up the manual and we get China English a little bit, and the words are all weird. So we want to have good user manuals. It's what keeps people coming back to our particular products. And by the way, just so that you know, somebody who's writing those manuals needs to be good or understand the hardware, software, or whatever's going into that. If they aren't, then you're going to get the China English. It's just going to be idiot English of somebody that wrote that but doesn't know what's going on. And so there's a lot of engineering that goes into the building of these, of just making them manuals. So it's something you want to think about. Recently, we'll talk more about this in a couple weeks when we do patents and intellectual property. But I just got finished up writing a patent, and I was very impressed with the lawyer. And the reason why I was impressed with the lawyer wasn't because he could speak legalese. All lawyers should be able to do that. I was impressed with the lawyer because he understood the hardware that I was trying to develop. And I thought that was very impressive. In other words, he understood enough about that to be able to write well about it in legalese. He kind of took two brains there, two understandings of that. And just so that you know, and this is kind of a side note for most people, electrical engineering by itself is boring. Mechanical engineering by itself actually is pretty exciting, but it's also very boring by itself, for itself. In other words, mechanical engineering, for the sake of mechanical engineering, is pretty boring. And what we need is we need to apply it to something to make it exciting. It's really cool to have two gears, right, that spin and they intermesh. But until you put it on a bicycle, it's pretty boring. It's just math. Does that make sense, what I'm trying to get across? So let me give you a really good example of where we take two different things, we apply one to the other, and all of a sudden the person that can do both becomes very valuable. When I went to graduate school, I'm an electrical engineer. I ended up in the anesthesiology bioengineering laboratory. I worked with a whole bunch of anesthesiologists. And that was extremely valuable because all of a sudden I had a place to apply electrical engineering concepts, which I still do. I still apply into the biomedical realm electrical engineering concepts, and I think that's really exciting, and it's very valuable. Think about every piece of overpriced medical equipment that you've ever seen in a hospital. And know that someone had to mechanically design that, electrically design that, they had to do safety inspections, they had to do all sorts of stuff like that. Those guys are paid, okay? Going back to the law one, if you guys want to make a lot of money but bore yourself to tears for the rest of your life, you can go on and get a law degree in patent law. And you guys can become a patent lawyer with a mechanical or an electrical or an engineering background, okay? As horrible as that sounds, they make buckets. We had someone pretty much as a recruiter when I was at my graduate school. They came for a seminar. He came, and he was from a law firm. He gave the seminar to a whole bunch of people. He said, "This is the greatest." He said, "If you want to go into this, when people come down, when they recruit people to come down to their law firm, they take them to a baseball game. It's like 5-star what they do for these people in hopes of getting these really good engineers crossed with legal people. Now, the downside of that, like what I said, is it's boring as all get out. But patent law by itself is boring, right? Patent law crossed with something else, with medical, with engineering, with something else other than itself is interesting. So that's something I hope you take advantage of, especially as maybe you consider continuing education. One of our faculty members has an MBA, okay, Master's of Business and Arts, right? I think that's what that is. And he always advocates for it, even though we all say that's stupid. He said he advocates for it. He thinks that it's one of the best things that somebody could do as a follow-on degree to an engineering degree. Okay. In general, engineering design improves existing technologies. In other words, you guys are not going to be doing bleeding edge research, hopefully, for your senior design project. Instead, you're going to be taking different components that already exist and mesh them into something that might be semi-novel, okay? As I scoped our projects, that's pretty close to where they're at. Does that make sense? We don't want to be developing a brand new sensor out of a MEMS technology device, okay? We want to be taking devices that already exist and integrating them. That's what engineering design is. The other side is a lot more physics than engineering. So we want you to be doing the design, okay? We want to find ways of applying existing technology. The other problem with this is, I get caught up in this a little bit too, is there's a big question that you should start off with is, does it already exist? Do we need to be putting our effort into this if we can just buy it off the shelf? Well, yeah, but it costs $5,000. Well, it's going to cost us $20,000 in development just to get it up to that. If you understand that, that's a really good concept to understand. That if it already exists, a lot of times you're just going to buy it. I'm very tempted a lot of times to just go and I'm like, well, I'm just going to write this software from scratch, okay, rather than buying that from MATLAB for so much. When in reality, it would take me less time and money over time to just go out and buy it. I get stuck in that trap a lot, like, oh, I can just build this from scratch. Be careful about that. Sometimes it's good, sometimes it's bad. In software, one of the reasons why I do that portion, why I will start building from scratch, is because it gives me more options down the road in the software to modify it. For some of you, that applies to both electrical and mechanical down the road as well. If you see the need for changing down the road, you might want to start at scratch, okay? Funny enough, I think someone told me this about SpaceX, and I'm not sure if it's true or not, but consider it anecdotal as what they'll do is they'll come up with a valve or whatever that they need for their rockets, right? And they'll say that's a really expensive valve, and so they'll re-engineer it themselves and build it themselves so that they don't have to buy this really expensive valve. It's kind of a unique valve that I guess they're going to need. So they'll re-engineer it and design it and do it themselves. Now there's danger in that as well. Do you guys think of the danger of re-engineering something that exists? Yeah.
You're breaking patent law.
You could be breaking IP. Yeah, that's bad. Anything else? Yeah. I think that's the big one. The people who have done this 1,000 times, there's a reason why they're selling the product. And so the person who was telling me was saying basically they're comparing SpaceX to the military rockets that they're firing, and they basically said they're so dangerous. They're saying SpaceX was very dangerous comparatively, and I don't know if that's true or not. That's what this one person was holding, and they said because they were being kind of careless in that sense about it. So sometimes it's all right to go back and start at scratch. Sometimes it's not. So you got to weigh those. Okay. Engineering design and development process. We want to talk about, okay, we've already gone through this. Okay, we've already done that. Okay, requirements. This is the difference between requirements and constraints, which is going to be the heart of what we're talking about today. A requirement is what you're given at the very beginning that says, I want it to do this. And you have a specific set of requirements. You are given something, you say, I want the gizmo to tell time. I want a compass in its stock, and I want it to shoot BBs. Okay, does that make sense? We can use the Red Ryder as the example. I want a compass in the stock, I want this thing that tells time, and I want it to shoot 100 BBs. That would be the requirements that you have. You need to talk about, these are examples. So reliable or redundancy is another one. I want to be able to shoot 100 times without jamming up, without refilling or something like that. Alarm or safety. I want it to be able to not fire when it's not supposed to. Okay. Packaging. I want it to come in a really great box and that box needs to have a target on it. Okay, you guys get the idea. Manufacturing. We need to have that thing be able to be manufactured. We need to be able to mass produce it. So these are all requirements, right? They're things given to you up front. There are testing requirements. Okay, we need to put them through a whole bunch of rigor. And there needs to be documentation. This is all things that are part of requirements. They're given to you up front. These are your goals. This is what you're going towards. These are things that don't necessarily constrain you. They're things that you're moving towards, what you're trying to build by the time you get done, as opposed to constraints. Constraints are what are thrust upon you as you try to get through this. These are obstacles in your way. This is something that you have to work around, but it's not necessarily something that you want to have as an outcome. So, for example, emission limits. Remember, we've got to go back to the person who did this. He may have leaned to one political side or the other. So, emission limits. Are there emission limits for your car? And today, yes, there are. If you're building a car, you have to figure out the emission limits. And then some companies go around and they say, "Oh, we can get around that, can't we?" Right? That's what VW did. They got in a lot of trouble for that. And so that gets us into a discussion of ethics, but that's a completely different thing. Okay, recycling. Are there recycling constraints on how you're going to build this thing? Well, we have to do all brand new materials, and EPA comes in and says, no, all new products must be made with 25% recycled materials. That's part of an environmental constraint. Human resources. So it may be something where they say, well, you have to use this demographic of engineers. And that's coming. There are companies and there are countries that say we have to, and for what it's worth, they say we have to have 50% women engineers of our engineering. That's really good for the women. Like, it's a guaranteed job, right? It feels that way. Anyways, so there's pluses and minuses to that, right? And I don't want to embarrass anybody, but there are things that happen like this. You have to worry about training, contractual obligations. Is there a contract? Do we have to work with this company to build it? These are constraints. This cramps your style, man. Manufacturability, do you have to use specific suppliers? Industrial standards, political, there's so many regulatory things. I just worked with the FDA just to start to do research. What a pain in the flipping rear end, and I'm not kidding about that. That has been a painful process, okay? And that's been a constraint on our project. It's not something we wanted to get out of it. It was something we had to work through. It's something we had to comply with. Okay? Are you in compliance with constraints? Okay. Is that it? Holy crap. Okay. So, I feel like I lost a page. There should be another page on here that basically says the difference between constraints and requirements is as follows. The requirements are things that you want your device or product to do or be. Constraints are obstacles in your way or things you have to work around in order to get it from point A to point B, from concept to actual reality. Okay? And I guess that's it. That's the end of the slideshow. Do you have any questions about that?
1 through 10.
Whatever you like. Go ahead and fill it out. I think it's in there. I think I gave you
Did you
this.
cover like 2 bullet points?
No, I did all of them. Human resources. Here, we'll make it easy. Human resources, is it a requirement or a constraint?
Constraint.
It's a constraint. That's something we already said directly. Okay. Working with a union, is that a requirement or a constraint? That's a constraint. We want our binoculars to see 300 yards. That's going to be a requirement. Okay. Let me see. Let me see if there's anything else here that's ambiguous.
What about the system interface?
System interface, requirement or constraint?
Requirement.
That's going to be a requirement. You're going to want to know what you're going for, what you're building. So some of these are tricky too because it says it's a constraint because. Be careful of those. It may be a constraint, but the reasoning may be false. Let's see. The difference between a requirement and a constraint, the specification of the system interface is a general requirement only impacts the cost and never the operational performance. Let me see. Requiring nuclear free, I think that's pretty easy to figure out which one that one goes into. Okay. Documentation, we can just, documentation, constraint or requirement. That should be a requirement. Okay. Requiring a contract to use union labor. Think about that one, considering what we already said. How the system is to be maintained or serviced, I think that one's pretty easy to decide which one that one is. Yeah? Okay, give me a specific one then if we're having problems, and we can talk about it.
Can you give me a few minutes to?
Yeah, go for it.